The truss shown is used to support the floor deck. The uniform load on the deck is 3,000 pounds per foot. The load is transferred from the deck to the floor beams, which rest on the top joints of the truss. Determine the force in each member of the truss and state if the members are in tension or compressed. Assume all members are pin connected. To begin this problem, first of all, we need to understand that a uniform load of 3,000 pounds per foot is our floor load, and this floor is supported by 5 beams. Therefore, this load will be distributed among these 5 beams, and we have to remember from our earlier videos about the tributary loading, and this is a one-way slab system. Therefore, the load across a span will be distributed equally among the 2 beams on the opposite side. Therefore, our first load, or our first concentrated load at G would be 3 times 6 foot, which is going to be 18,000 pounds. Our load for joint I is going to be 36,000 pounds, and it's going to be the same for H and G. And finally for F, it's going to be 18,000 pounds. Now that we have our concentrated load, now we can determine our external reaction forces for this truss. Our horizontal force A is going to be 0 since there isn't any external horizontal force acting on this truss. Our vertical AY is unknown, so is our EY. To determine our vertical reaction forces, we're going to take a moment about the point A. We're going to have counterclockwise EY, and it's 48 feet away. Then we have clockwise thrice 36,000 pounds concentrated load from the floor. We can either have it separated, or we can do it the way I'm doing, which is going to be simply 12 plus 36 plus 24 foot. And then we can have our clockwise 18,000 pound, and it's 48 feet away. All equals to 0. Our solution for EY is going to be 72,000 pounds. We can see that this truss is symmetrical from our member HC. Therefore, whatever force we have on the right hand side, we're going to have the same force for our left side. Therefore, we know by inspection that our AY is going to be equal to our EY, which is 72,000 pounds. Now we can start solving this problem. So we're going to start it from joint E. At joint E, we have external reaction force of EY, which is 72,000 pounds. We have unknown reaction force FE, and another unknown force DE. We can sum the forces in y direction to find our solution for force FE. All equals to 0. Solving for FE, we get our solution as 72,000 pounds, and this member is in compression. Now we can sum the forces in extraction to find our solution for force DE, but here we only have one horizontal force acting on this truss. Therefore, our force DE is going to be 0 pounds. Now we can move on to our joint F. At joint F, we have our known force FE. We have our external reaction of 18K. We have our unknown force GF and our unknown force DF. To solve this problem, we're going to start with vertical equilibrium equation. So we have negative 18K, and we have a positive 72K, and then we have our vertical component of DFE, which is going to be And before we find the vertical component, we need to find the hypotenuse or the length of the member DE, which is simply going to be the square root of 12 feet plus the 16 feet squared. On this, we get our solution as 20 feet. Therefore, the vertical component for force member DE is going to be negative force DE times 16 divided by 20, all equals to 0. Solving for force DF, we get our solution as 67.5 thousand pounds or 67,500 pounds. And this member is in tension. Now we can sum the forces in extraction to find our solution for member GF. So we're going to have negative GF, and then the horizontal component of force DF, which is going to be simply force DF, which is 67.5 K times 12 foot divided by 20 foot, all equals to 0. Solving for force GF, we get our solution as negative 40.5 K. This means we assumed our vector direction to be in the wrong side. Switching the vector sign, we get our positive solution, and this tells us that our member is in compression. Now we can move on to joint G. At joint G, we have our known force GF, which is in compression. We have our external reaction force 36K. We have our unknown force HG and our unknown reaction force from member GD. As you have already imagined by looking at this free body diagram, the solution is pretty simple for this particular joint. So it's simply going to be force GD is going to be the same as the opposite reaction force, which is 36K, and it's going to be in compression. And then our force HG for this case is going to be 40.5K, and this member HG is also going to be in compression. Now we can move on to our joint D. At D, we have our force GD. We have our diagonal force reaction from DF. Pardon me, DF, yes, it's DF. And this is going to be 67.5 K. Then we have horizontal force from member DE, which is 0, so I'm not even going to bother writing down. Then we have our unknown member HD. And finally, the other unknown is member CD. Okay, so to begin, we can sum the forces in y direction in order to find our solution for member HD. We're going to have a vertical component of member HD, which is simply 16 divided by 20. And then we can have negative 36K from member GD. And then positive horizontal component of member DF, 67.5K times 16 over 20, all equals to 0. Solving for member HD. Solving for HD, we get our solution as negative 22.5K. What this means is we assumed our vector direction in the wrong direction. Switching it over, we get our solution as positive, and this also tells us that this member is in compression. Now we're going to do the same for our horizontal reaction to find our solution for member CD. Member CD in the negative direction, then the horizontal component of member HD, which is 22,500 pounds times 12 over 20. Then we have the horizontal component of the member DF, so 67.5K times 12 over 20, all equals to 0. Solving for member CD, we get our solution as positive 54K. This tells us our member is in tension. You can remember from our earlier videos, if a member is perpendicular and it doesn't have any external force, it is considered a zero force member. Therefore, member HC is going to be simply 0 pound force as well. And this solves our solution because whatever values we got are for our right